Alright guys, welcome to this pre-calculus review video, and today I will just be going through everything in this packet here, and I'm just going to, go through this relatively fast pace, try to explain how to do these things as I go through them. So let's just begin with question 1a, and here what we want to do with this one is we want to recognize an exponent property. Negative exponents, that means it's 1 over that. And since these are being multiplied, we can just think of this as x over, and remember, something to the 1/2 is just the square root. So the square root of x minus 1. And now this, there is no negative, so this is just 2 times the square root of x minus 1. And now what we want to do is we want to get a common denominator. So we multiply square root of x minus 1 over square root of x minus 1 for just this part. Now what this leaves us is x over square root of x minus 1. That fraction does not change. And then we get 2 times x minus 1 all over the square root of x minus 1. Now, continue working. Since we have a common denominator, we can now just add these two. And x plus 2 times x, and then this is going to be 2x. This is going to be negative 2. So, plus 2x minus 2 all over the square root of x minus 1. And what that leaves us with is 3x minus 2 over the square root of x minus 1. And if we were to rationalize this by multiplying it by this again, we could get 3x minus 2, don't forget your parentheses, square root of x minus 1, all over x minus 1. So these here are our potential answers to this problem. It just depends if you want to rationalize it or not. Now we are going to move on to question 1b. So cubed. And to work through this one, we're going to notice that if we were to just treat these as their own things, we can factor this out as if it was just an x or a y. Just because there's an x minus 2 doesn't change anything. And we're always going to choose the lowest exponent we see, so it's the least greatest common factor. And what that means is we can bring out an x minus 2 cubed out front, and here 3x to the 4th 3x cubed. The lowest one here is 3x cubed. So times 3x cubed, and I'm just going to use brackets here so we can convey this as what we are factoring out. And what that leaves us with is a 3x, and then plus x minus 2, because this is 1 power greater than x minus 2 cubed. So now what this means is x minus 2 cubed times 3x cubed times 4x minus 2. And what that means, we can factor out a 2 here. So bring 2 all the way out to the front. 2 times x minus 2 cubed times 3x cubed, all cubed, times 2x minus 1. And that is the simplified form of question 1b. Now, here we have, for question 1c, the difference of 2 cubes. And if you don't know what it is, allow me to write the formula. And allow me to show you. For a difference of 2 cubes, we have to have 2 things that are cubed. We can tell that 8, that's 2 cubed, right? And 125, that's 5 cubed. So, you can say that a equals 2x, and b is just 5. So, working through this, we get, and of course, the difference of 2 cubes formula is a minus b times a squared plus ab plus b squared. So, now what that tells us is we can go ahead and just apply this, where 2x is a and b is 5. And let's do that. So this becomes 2x minus 5 times 2x squared, and don't forget to square the 2, plus 2x plus 5, 5 times 2, that's 10, 10x, plus 10x, plus 25, and that's the whole problem. These tend to be relatively simple. All you have to do is remember the formula. And now we have question 1d. And we cannot just start canceling out. What we want to do is factor it out. So, applying what we did with those earlier problems, you can see x plus 3 cubed, lowest common factor of that, and 2x plus 1 squared, lowest common factor. So, doing such, we get x plus 3 cubed times 2x plus 1 squared. And in brackets, we have what's left, 2x plus 1 plus x plus 3. And don't forget that this is all over x plus 3 to the 4th. And instantly, since we know that these are all multiplied together, we can just cancel terms out now. And this is not going to exist, it's just going to become a 1. And this is just going to be an x plus 3. So, what we have left here is 2x plus 1 squared times, and now we're just going to add this together, 3x, right, plus 4. So, 3x plus 4 all over, all over x plus 3. And of course, it's not necessary for the parentheses, but this is just what we have. And next here, we have x cubed minus 9x squared minus x plus 9. And this, we can see is factorable because these two look pretty similar, but we just have to take some numbers out, and we can see that we can pull out a common factor. So let's begin. And typically, you're going to look at the two highest term powers, and you're just going to take on x squared, because that tends to be the greatest common factor. And this just leaves us an x minus 9. And now what we want to figure out is, how do we make this x minus 9? Well, it sort of looks like a negative one, as if we flip the sign. So, if we were to factor out a negative 1, then we can do minus 1 times x minus 9. And factoring this out, we get x minus 9. That can come out front, but then we're left with this, x squared minus 1. And we're not quite done, because isn't this a difference of 2 squares? So what we can do is we can make this x minus 9 doesn't change, but then we can make this x plus 1 times x minus 1. And then that gives us the answer to question 1e. And now we're going to go on to 1f, which is, so what this tells us, as we can see here, there's a variable cubed. That's a pretty good sign that we're working with a difference of 2 cubes, or a somewhere difference of 2 cubes. And now just applying the same thing, except I'm not going to write a equals or b equals. We can just see this is just going to be 4y minus 3 times this squared, 16y squared minus 12y, and then this is just going to be plus 9. Here we have question 1g. And this one might seem a little daunting at first, but if we just take it step by step, we can work through this. Now, applying the same property we did earlier to the negative 1/2, what that just means, it's 1 over the square root of this, and since they're being multiplied together, we can just do x plus 3 squared over the square root of x minus 1. So, now what we can see is, now we have to subtract this part, and we don't want to factor anything out just yet. So, now we see this is to the negative 3/2. Well, that means this number is what power it's raised to. This is the radical, that's fractional exponent properties. So, this then becomes x plus 3 cubed over the square root of x minus 1. Well, x minus 1 is cubed. And now you may be wondering, how do we get a common denominator here? Why, we can see if this is to the 1/2, and this is to the 3/2, we should probably go to try to get it to the 3/2. So, let's think about this. What, again, x minus 1 to the 1/2 times x minus 1 to the 1st. Isn't that just x minus 1 to the 3/2? So, if we were to multiply this by x minus 1 over x minus 1, we can get a common denominator. And just this left side, of course. So, x minus 1 over x minus 1. And what this tells us, we just multiply them together on the top. X minus 1 times x plus 3 squared over the square root of x minus 1 cubed. And then this is just going to be minus, it's going to stay the same, x plus 3 cubed over the square root of x minus 1 cubed. Now, what we want to do is we just want to combine these fractions. So this is going to become x minus 1 times x plus 3 squared minus x plus 3 cubed all over the square root of x minus 1 cubed. And what we can do here is we can just factor out the x plus 3 squared. And I'm going to work to the right now. So this is going to be x plus 3 squared. And we're going to use the bracket because what we have left here is x minus 1 minus this thing in parentheses, x plus 3. And all over the square root of x minus 1 cubed. And to drop it down just a little bit, this is going to be x plus 3 squared. Distributing the negative, this is minus x, this is minus 3. So this is just become x minus 1 minus x minus 3. And of course, we can see these x's cancel out. This just becomes negative 4. So in fact, if we were to do, we could write it negative 4 over here. However, we can just write the negative 4 out front. So that this becomes negative 4 all over the square root of x minus 1 cubed. And you could attempt to rationalize this, but there is no. And for the last question on page 1, we have 1h. And what this is, 2x plus 5 squared times x squared plus 2x plus 5 cubed times 2x. Now, this might look a little confusing because we can factor out this, but what do we do with this x squared? Well, we can just do this. So, if we want to make it a little clearer, we can always just write this 2x in expanded form. So this becomes this. Everything is the same, except this is now times 2 times x. So it's a little clearer. We can take out a common factor of x. You don't necessarily need to do that intermediate step, but if it lets you remind yourself. Now, factoring out our 2x plus 5 squared times our x, then what's left is this x plus, don't forget the 2 at the end, so times 2x plus 5 all times 2. And then, oh, whoops, there should not be an extra parentheses there. And what this is telling us is we just have to multiply this out and then we'll have our answer. So, just the inside. So 2x plus 5 times x times, multiplying this is 4x, this is 10. So x plus 4x plus 10, that is going to be 5x plus 10. Then, what we see, we can multiply a common factor of 5. And I also like my x out front, so you don't confuse it with multiplication or anything like that. So this becomes 5x times 2x plus 5 times x plus 2. Now, what we have here for question 2a is going to be a complex fraction. And to deal with these, we got to multiply the numerator and the denominator by something over that same thing. And we want to eliminate these fractions on the top. So we're going to have to multiply it by y times y minus k, right? So this becomes y minus k times y. Because if we were to do this, this would eliminate both parts. Both of those complex denominators on the top. And now we have to do the same on the bottom for it to stay the same value. Now, distributing y minus k, these are going to cancel out, which just leaves us with y minus, this is going to cancel out the y, so minus y minus k. And then this is going to be all of that over yk times y minus k. And nothing here, we just have to distribute everything into the k on the denominator. Now, what we see here, this is y minus y plus k over yk times y minus k. And again, going on, y minus y, that's 1. This is just k over yk times y minus k. But this has a common factor of k, right? So if you just cancel out the k's, this becomes 1 over y times y minus k. And that leaves us with our fully simplified complex fraction right there. Now for question 2b, we have this complex fraction. And now what we want to do is it's going to be the same thing. Here we have a complex denominator, and that's going to be x. So we're just going to multiply this by x over x, and that will simplify things to have just one denominator, one numerator. So, as we can see, these cancel out, and this is just going to become 3 minus 6x all over x times x plus 2. And this is really it for this problem. You could, of course, I guess, factor this out. So you got 3 times 1 minus 2x over x times x plus 2. And that's another potential solution, but it doesn't really matter. They're all equal. They're all the same thing. Just now here we have our last and arguably hardest complex fraction. So we're just going to get straight into this. If you wanted to eliminate the stuff on the top, that means we're going to have to multiply this by xy over xy. But again, we're also going to need to multiply this by x plus y over x plus y, because we want to get rid of the denominator on the bottom. So just working through this out, 3 times xy, that's 3 over x times xy, x are going to cancel out. This is going to become 3y, and don't forget that x plus y, minus 4, the y's are going to cancel out, so this becomes x times x plus y. And next, we have all this over the x plus y's here, they're going to cancel out. This just becomes over 6xy. Now, working through this, we are just going to distribute this, see if there's any common terms we can eliminate. So this is going to become 3yx plus 3y squared minus 4x squared plus minus 4yx. And then what we see, divided all by 6xy, this is going to simplify out. So 3yx, 4yx, we can subtract these, and this becomes 3y squared minus 4x squared minus 1yx all over 6xy, and that is question 2c simplified. Here we have a relatively simple piecewise function question, and this is question 3, just to indicate, and it is asking us to basically just what is f of 2, f of 0, f of 5, and f of 4. So f of 2, we just look at what the function is defined as when it's at this point. When it's less than or equal to 2, it's 2x. So this is equal to 2, so this is just 2 times 2. And this is, of course, equal to 4. So a is 4. And then f of 0, when it's less than 2, 0 is less than 2. That's just 2 times 0. 2 times 0, which, of course, is equal to 0. And that's that question. Now c, f of 5, we know it's not in this range because it's greater than 4. So 5 is greater than or equal to 4. It's greater than 4. So we just multiply 3 times 5 minus 5. And what this is just going to be 15 minus 5, which then equals 10. And now, when x is greater than or equal to 4, this right here, it is equal to 4. So 3 times 4 minus 5, this is 12 minus 5, and this, of course, equals 7. And that is question 3 wrapped up. Now we have question 4. X to the 3 halves plus 2 over root 3 squared. And as you can see, this is just like any other squaring a binomial. So let's just apply it. And we know for binomials, squaring this, it's just going to be, if this was a plus b squared, all squared, this equals
a squared plus 2ab plus b squared.
So if we just apply this, a is x to the 3 halves and b is 2 over root 3, we can simply solve this. So x to the 3 halves, so we're going to have x to the 3 halves squared plus 2 times a is x to the 3 halves, then times 2 all over the square root of 3. We multiplied a and b, and then plus 2 over the square root of 3 squared. And here, these are pretty simple to work out. So x to the 3/2 squared, using exponent properties, these are just going to cancel out. So this becomes x cubed plus, this is 2 times 2x to the 3/2 over 3. So this becomes plus 4x to the 3/2 over the square root of 3. And then 2 over the square root of 3 squared is just going to become 4 over 3. We just squared the top and the bottom. And what looked a little challenging at first becomes rather simple, where this is just our final answer. Now, what we have here is a word problem asking us to write the equation of the line that passes through the point 3, -1 with slope 5/2 in point slope form. And point slope form is simply just y minus y1 equals m, where m is the slope, times x minus x1. And y1 or x1 are just a point that we're given, either any point if you are given multiple. And what we can just do here is we can just plug these points in. Y, we don't have to write anything. And it wants us in point slope form. So this is just going to be y minus -1, that's plus 1. And then 5/2, we're given the slope. So 5/2 times x minus 3. And that's our final answer. Now, for question 6, we have a very similar problem, except it tells us that it's parallel to y equals 4x plus 1, and it passes through a different point. And what this tells us, if it's parallel to a line, that means it's going to have the same slope, so that way they'll never touch. So we know our m equals 4, and we have our y1 and x1 just given to us, and it's still in point slope form. I just didn't fully write that out. And this just becomes y minus 3 equals 4 times x minus 2. And that is your final answer for this problem. Here we have this problem that says, very similar to the last two, write the equation of the line that passes through the point -1, 4 and is perpendicular to 2x plus 3y equals 6, put in point slope form. And this one can be rather easily worked out, and we need to keep in mind that it's perpendicular, and point slope form makes this really easy to work with. So what we want to do is set this into slope intercept form so we can figure out this one's slope. So this means 3y equals -2x plus 6, and then dividing both sides by 3, we get y equals -2/3 x plus 2. And what that tells us is that the slope of this line is -2/3. But we want something that's perpendicular to it, which means we're going to have to take the opposite reciprocal. So m, and I'll use this as the perpendicular symbol, equals +3/2. Now, what we're going to do, we're just going to plug it in to the slope intercept form. And what that would be, y minus y1, which is 4, equals 3/2 times x plus 1. And right there, that is our solution. Here is question 8, and what we want to do with problems like these is we want to move all what we're solving for, and in this case, I didn't write it, but we are solving for y prime. So we want to move all the y primes to one side. So what that means, minus y prime, minus y prime, and that means this is going to become x y prime minus y prime plus y, and this equals 1. But now we want to move the y to the other side, which means x y prime minus y prime equals 1 minus y. Next thing that we want to do here is we want to factor out this y prime, because if we do that, we get y prime times x minus 1 equals 1 minus y. And what this is telling us, if we just divide both sides by x minus 1, then we're just going to have y prime. And that means y prime equals 1 minus y over x minus 1. And that's our answer. And what we really just did here is we moved both the y primes to one side, factored it out, and just divided, and we solved for it in terms of y prime. And that is typically what we want to do when it comes to these type of questions. And here, it's asking us the same sort of thing, but now, this isn't question 9, this is 8b, my apologies. And what it's telling us to do here, it says that, and solving for y prime, we get y prime sine y. We're going to subtract this to the other side, and then we're going to add this to this side, the 3xy prime. So 3xy prime, we have our y prime on one side, and this is going to become cosine of x minus 2xy. And what that means is we factor out our y prime times sine of y, plus 3x equals cosine of x minus 2xy. And last step that we want to do, just divide. Y prime equals cosine x minus 2xy all over sine y plus 3x. And basically, as we can see, it doesn't matter if there's a cosine or a sine or anything like that. If we see an equation of this form, we typically want to just factor out the y prime, divide, and we'll get our answer just like that. Here, this question is asking us to find the domain of the function f for this and this. Now, to find the domain of a function, we have to find when it's not going to be defined, because otherwise it would just be from negative infinity to infinity. But let's look at this first part A. This is a square root function, and what we know about square roots is if the argument or what we put into a square root is negative, then it's going to have an undefined result unless we go to the complex world. So what we want to do here is instead just find when this is equal to 0, and that would mean for any number less than that, this is just going to become negative and not be a part of the domain. So let's just look at the inside. So we have to only look when 2x plus 3 is equal to 0, and what that means is 2x equals negative 3, x equals negative 3 halves. And what that tells us about the domain is that from negative 3 halves to infinity is where this function is defined. And we know that because if this was to be any number less than that, this would be negative and it would not be a part of the real plane. Now, let's move on to part B. So we have a rational function here, 1 over a quadratic, and to find the domain of a rational function, we just have to find what the denominator is equal to 0. And to do this, we're going to set x squared minus 2x minus 2 equal to 0. And what this means is we can try to factor this, but we'll see that we're not going to get any sort of rational pairs. So we're going to have to use the quadratic formula. And I'm going to do this a little bit over here. So x equals negative 2 plus or minus the square root of b squared, or minus 4 times negative 2 times 1. So this is just going to be plus 8 all over this 2a, 2 times 1. Now we get x equals 2 plus or minus square root of 12 over 2. X equals 2 plus or minus 2 root 3 over 2. X equals 1 plus or minus the square root of 3. Now, working from that, we can just use this to find the domain of this function. So, the domain here is going to basically stop whenever x is equal to this, but it will be defined for everything else. So from negative infinity to, and we're going to go to the lowest point because we're going to write it in ascending order. 1 minus root 3. 1 minus something is always going to be less than 1 plus it. So 1 minus root 3. And now we're going to use the union to indicate that this continuous there. And now we're going to continue from 1 minus root 3. But now we're going to go to the other root, 1 plus root 3, because that's the next time the function isn't defined. And one more union, and we're going to go from 1 plus root 3, oh, did not mean to close it, and just off until infinity. And as we can see here, there weren't any brackets. This is all parentheses. And that right there is the domain of function 1 over x squared minus 2x minus 2. All right, everybody, on question 11, we were asked to find the x and y-intercepts of these two functions. And here, let's just jump right in. So we have a rational function here. Solving for the x-intercepts, we set 0 equal to 2x minus 1 over 3 minus x. But we multiply this, we're going to get 0. So that just means 0 equals 2x minus 1, 2x equals 1, and that means x equals 1/2. So we can write x int 1/2 0, and now we have to find the y-intercept, and that means y-intercept 2 times 0 is 0, and that's -1, and then 3 minus 0 is 0 over 3, which means that our y-int is going to be 0 and -1/3. And now we have this equation, but this is a quadratic, and to find its zeros, we just factor it, and the y-intercept is always going to be the constant term, so we can instantly say the y-int is 0, -3, and now solving for the x-int, we do 2x squared minus 5x minus 3 equals 0. However, there's a cool trick with quadratics with the leading coefficient. If you take this out and multiply it by the constant term, we can get another quadratic, x squared minus 5x minus 6, which equals 0. Then what we do is we can just factor this one, which is going to be x minus 6 times x plus 1 equals 0. Then we just take each of these roots and we divide it by this leading coefficient. So it's going to be x minus 3 times x plus 1/2 equals 0. So x equals 3 and x equals -1/2. So now we have our x-intercepts, and this is just a useful thing. I'll link a video in the description to this trick and where I learned it, the intuition behind it, all that. And x-intercepts are 3, 0 and -1/2 0. And that is question 11. We are on question 12. Now question 12 is asking what are the points of intercept between y equals x squared and y equals -x squared plus 4x. And what we do here is we're just going to set these two equations equal to each other, which are already set equal to y. So what that means is x squared equals -x squared plus 4x. Adding x squared and subtracting 4x, we get 2x squared minus 4x equals 0. So now we can factor out a 2x. So 2x times x minus 2 equals 0, which means 2x equals 0, so x equals 0, and x minus 2 equals 0, so x equals 2. And what we can do is to find the actual points, because we just have the x values, we're just going to plug it back into this one. You could plug it into either one, since you should get the same answer if they are points of intersect. So 0 squared, that's going to be 0, so our first point is 0, 0. I'll write that over here, 0, 0, and the other point is going to be 2 squared, so it's going to be 2 fourths. And these are our answers for question 12. Now we are on to question 13. So it wants us to find g of x plus delta x minus g of x all over delta x. And if this looks familiar, this is the difference quotient, except there is no limit here. So, and for this, I'll only be looking at part A. Part B is very tedious, but sort of self-explanatory, where you find a common denominator. And here we are given g of x to be equal x squared plus 3x minus 1. And what we want to do now is we're just going to plug this in. So this is x plus delta x squared plus 3 times delta x. No, 3 times x plus delta x. My apologies. And minus 1 minus then g of x is going to be, I'm just going to apply the negative right now, minus 3x plus 1, and this massive fraction all over delta x. Expanding, we get x squared plus 2 delta x plus delta x squared plus 3x plus 3 delta x minus 1 minus x squared minus 3x plus 1. And now these terms cancel. X squared negative x squared, 3x negative 3x, 1 and negative 1. And what this leaves us is, and don't forget this was all over delta x, which now leaves us with 2 delta x. Oh, and don't forget this is times x. I forgot that. 2x times x, 2 delta x times x plus delta x squared plus 3 delta x, and all of this is over delta x. And one thing you can notice is that all of these have a common factor of delta x. We can just cross it out, and what this leaves us with is 2x plus 3 plus delta x. So for question 14, here we have f of g of x, where f of x is 1 over the square root of x, and g of x is x squared minus 5. F of g of x, this is a simple composition of functions. So we're just going to plug in g of x every time we see x, and this is just going to be, alright, f of g of x equals, excuse the terrible writing there, but f of g of x equals 1 over the square root of x squared minus 5. You could rationalize this, but this is your answer. This is it. Alright, so for question 15, here we have some logarithm questions. And what we want to do with these is, of course, this is the natural logarithm. So let's first apply one rule of logs. When you see something raised to another power in a log, you can multiply it, you can bring it out and treat it like it's multiple. So 7x times ln of e, and this is equal to 15. And now, since ln is just log base e, and we're taking the natural log of the base, it's just going to be 1. So this is 7x times 1. So 7x equals 15, x equals 15 over 7. That is our answer for part A of question 15. Now we're going to move on to part B. So e to the 2 ln x minus x squared plus x minus 3. This question may look a little daunting. Just had to check, I was writing it down, right? But we can actually want to do is we want to condense this. So this becomes e to the ln of x squared minus ln of x squared plus x minus 3. And as we know with logs, you can, when it's subtracting the 2, you can just treat it like a denominator. This equals 1. So e to the, now this is going to become natural log of x squared over x squared plus x minus 3. And now what we do here is we see e raised to the natural log of something. We can just cancel those out, and then we get x squared over x squared plus x minus 3 equals 1, which then again we can do, we multiply the denominators and we get x squared equals x squared plus x minus 3. And this next step is rather simple. Subtract x squared, add the 3, so 3 equals x. So in other terms, for question this, for part B, we have x equals 3. And now we're going to go on to part C. And what we can do here, we want to solve for this. So it's 4 to the x plus 3. This equals 22. And what we can do here is take log base 4 of both sides. Log base 4 and log base 4 of 22. What this allows us to do, cancel these out. This means x plus 3 equals log base 4 of 22, which means x equals log base 4 of 22 minus 3. And that's the answer for part C. This one's rather simple. And lastly, for part D, ln of x minus ln of x plus 1, we can rewrite this to ln of x over x plus 1. And this, of course, is still going to be equal to 1. We just condense the logarithm using the subtraction property. And now what we want to do is raise e to the power of both sides. This isn't going to change the equality. And what that means, we can cross out both of these, e and ln. And this means that we have x over x plus 1 equals e, because e to the first power is e. Now, what we want to do is we want to multiply out the denominator. So e x plus e, we just distributed. And then now we want to isolate. So x minus ex equals e. X times 1 minus e, we factor out the x, and this equals e, which then means x equals e over 1 minus, oh my gosh, not 1e, 1 minus e. But there's something just slightly off about this answer. Because if we think about the value of e, isn't it about 2.7? And 1 minus 2.7, that's going to be a negative number, even if this is a positive. So, wouldn't that mean if we plug this back in, we'd have a negative number in a log? Which isn't possible. We can't have a negative number in a logarithm. So, what we can say is that this log, that even though we got what looks like a real answer, this actually has no real solutions. So, that is the answer to part D of question 15. So, here we have these two functions, 3x cubed minus 27x over x cubed minus x squared minus 6x, and it wants us to find the asymptotes, vertical and horizontal. So one thing I want to do here is start simplifying it. So I can see we can factor out an x, a 3x even, and then we get 3x squared minus 9 over, and here on the bottom we can also factor out an x, so we get x squared minus 6x, no, not minus 6x, minus x minus 6. And what that means, we can cancel out these x's, and this becomes 3 times x plus 3 times x minus 3 all over x minus 3 times x plus 2. These cancel, we get 3 times x plus 3 over x plus 2. And what this tells us is x has a vertical asymptote when it is equal to -2. So asymptote VA, x equals -2. And now our horizontal asymptote, since this is the same degree on the top and the bottom, it's going to be the ratio of these two. So 3 over 1, 3x over 1x, this is just going to be y equals 3. So that's part A. Now part B, what I want to do is factor the top and bottom to get a better understanding. This is x minus 4 times x plus 2 over x minus 3 times x plus 1. What this tells us is that VA's, we have multiple vertical asymptotes at x equals 3 and x equals -1, and our horizontal asymptote, since these are the same degree and same leading coefficient, it's just going to be y equals 1. And that is how we get the asymptotes for this equation. Now, here we have question 19. Cosecant theta equals 13/5. It is in quadrant 2 with a secant theta. And what this tells us is, we know this is going to be negative automatically, but let's go ahead and start working with this. So we know cosecant theta equals 1 over sine theta, and that means 1 over sine theta equals 13 over 5. Taking the reciprocal of both sides, we get sine of theta equals 5/13. So now what we want to do is since we know sine of theta, we can solve for cosine of theta. So, and we can use this with the Pythagorean identity, that sine squared theta plus cosine squared theta equals 1. So, what we can do here is sine squared theta equals 25 over 169, and plus cosine squared theta, this equals 1, and subtracting cosine squared theta equals 169 minus 25, that is going to be 144 over 169. And then we see cosine theta, and we know it's the second one, so it's negative. This is going to be negative 12/13. And now for secant, that's just 1 over cosine. So secant theta equals negative 13/12. It's also possible to do this via some triangles. You can just draw triangles too and work with those. But this is one method. Now for question 20, simplify cotangent theta over cosecant theta. What we want to do is we want to change that into their function. So cotangent is defined as cosine over sine, and then we can divide that whole by cosecant, which is 1 over sine theta. And what we can do here is just cross these out, and then we get, this is just cosine theta over 1, which is cosine theta. Here we are given the problem, find sine of 2a if sine of a equals 1/4, and it's between a is between 0 and 5/4. So what we want to do for this problem is we are going to solve, we know the sine double angle formula, which is we'll use sine theta cosine theta equals sine of 2 theta, correct? So what we're going to use here is we're going to find the we're going to find what cosine theta is. So what this means is if sine a equals 1/4, that means, and this is a constant from the Pythagorean identity, that means sine squared a plus cosine squared a equals 1. What this means is 1 over 16 plus cosine squared a equals 1. Cosine squared a equals 15/16. Cosine of a equals root 15 over 4. So now what we're going to do is we're just going to plug this into the equation here. So 2 times 1/4 times root 15 over 4. This is 1/2 times this. This becomes root 15 over 8. And that is our final answer to this problem. Now here we are given this tangent of the arc cosine of x over 3. And what this question is asking us is to put this into an algebraic form, which might be a little confusing at first, but it helps if we draw a triangle. So what we can do here is draw a triangle as such, and let's just define an angle theta. It doesn't matter, this could be anything. So what arc cosine is saying is that when you apply this function to it, you're going to get what original thing is. So x over 3, what that means is that cosine is adjacent over hypotenuse. So x over 3. So arc cosine of this is going to get you x over 3. So now what we have to do is solve for this side, which we'll just temporarily call y. So what that means is x squared plus y squared equals 9. Y squared equals 9 minus x squared. Y equals the square root of 9 minus x squared. So we can replace y with such. And then what that means, the tangent of this is just going to be opposite over adjacent. So the square root of 9 minus x squared over x. And to better explain this arc cosine thing here, this is supposed to make it such that when we take the arc cosine of this angle, we're going to get x over 3. Because it's the sides. Arc cosine is referring to the sides. Tangent is referring to this angle. So, and that gives us our answer after we do some Pythagorean problems here. And what it wants us to do is just find two values of theta between 0 and 2 pi where this is true. So, if we want to think, we can draw a circle. And we know cosine is the x value. So, when is the x value about root 2 over 2 or 0.7? So, if we think about our walk across the unit circle, you can think, well, the first value is going to be pi over 4. Well, wouldn't this other point, right, also drop down and be the same? So, if this is pi over 4, then this is going to be 2 pi minus pi over 4, which is some pi over 4. So, that just allows us to visualize our answers of pi over 4 and 7 pi over 4. Next, we have cotangent of theta equals negative root 3. What this is telling us is 1 over tangent theta equals negative root 3. In other words, we're looking for when tangent of theta equals negative root 3 over 3. And now this is a little easier with the circle because we can just visualize the tangent as the slope of the line that is going through our unit circle. So negative root 3 over 3 is going to have a slope that's like this. And if we think about our angles, this is 5 pi over 6, this is 11 pi over 6, which means our answers are going to be 5 pi over 6 and 11 pi over 6. What we have here are two trig equations, and what we're going to do is solve for theta. So, and this is on the interval from 0 to 2 pi, so we're going to have a list of values, not plus 2 pi n. Now what we're going to do here is we're going to solve right here. So sine squared theta equals 1/2. We divide both sides by 2, take the square root, and of course we can't forget our plus or minus 1/2. Now all we need to think, not 1/2, root 2 over 2, which is the same as 1 over root 2. So what we need to know, when sine of theta is equal to root 2 over 2 at any pi over 4, and this is plus or minus, so what this tells us is that theta equals all the pi over 4s between 0 and 2 pi, so pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Next, we have this equation, cosine squared theta plus sine theta equals 1. And whenever we see this, we think, you want this in all terms of one function. So one thing we notice, cosine squared theta is the same as 1 minus sine squared theta, and then we add, we just have the rest here. This equals 1. Now, rearranging, negative sine squared theta plus sine theta, and we have to subtract our 1 here, so this and this are going to cancel here, so plus 1 minus 1 equals 0. So canceling out, now we have negative sine squared theta plus sine theta equals 0. What we want to do is just flip the signs real quick. So I guess sine squared theta minus sine theta equals 0, because they're both set equal to 0 anyways. Now what we can do, factor out a sine theta. Sine oh, this equals 0. Then sine theta times sine theta minus 1 equals 0. So sine theta equals 0 from 0 to 2 pi. That is from on 0 and it's on pi. If you want, we can draw the circle. It's at a height of here, and the height is 0 there and there, so it's 0 and pi. Next, we have sine theta minus 1 equals 0. That means sine of theta equals 1. In other words, if we were to think about this, it's at its peak right here. This angle is pi over 2. So theta equals pi over 2. And just listing these out in succession, we get theta equals 0, pi over 2, and go high up, pi. And that will conclude our video. There is a little bit more in the packet, but most of it is self-explanatory and not needed. Thanks for watching. This is a really long video. Thanks.